Hello class, welcome to Geometry Lesson 8.3, which is all about the law of sines. By the end of this lesson, you should be able to use the law of sines to solve problems. So, first of all, what is the law of sines? The law of sines is when you have like two angles on a side or two sides and an angle, and you want to solve for one of those missing measures. A really important thing for the law of sines is knowing what angles and sides are opposite of each other. So just a reminder, if these two sides make up angle A, that means the side that doesn't make up angle A is going to be denoted by a lowercase a. So angles are capital letters and sides are the lowercase. So then same with angle B. These two sides make up angle B, so the side that is not highlighted, that does not make up angle B, is the lowercase side B. And same thing goes for C. You have the two sides that make up angle C, and the side that does not touch or make up that angle C is lowercase c, and it's opposite. Now, the law of sines is just a ratio. So you do the sine of the angle over the side, then you do the sine of like angle B over side B, sine of angle C over side C. Okay, so it's a lot of cross multiplying and dividing. Hopefully you guys are still feeling pretty comfortable with that. We did a lot of that in chapter 7. So example 1, use the law of sines to find a side length. What is YZ? And we want to round to the nearest 10. So first I look, and I recommend find the side and angle that you have both the matching like angle and side for. So here I have a 77 and I have a side. So what I'm going to do is I'm going to start by setting up my proportion with that. So I'm going to say sine of 77, because that's my angle, over my side 7 equals, and then I have a 51 degree angle, and that's opposite the side I'm looking for. So I'm just going to call that side X for now. I know the law of sines had 3 different fractions, but in order to solve, you only need 2. Okay, so less work. You guys should be cheering right now. What you are going to do is you're going to cross multiply. So I would multiply X times sine of 77. And I would say that equals 7 times the sine of 51. And I will do this to make it a little easier to see the angles. Okay. Next, to get x by itself, I would divide both sides by sine of 77. And then I'm left with x equals, and if I plug that into my calculator, I can type 7, hit the sine key, 51, close my parentheses. Then I can hit the division key and hit sine 77, close parentheses, enter. And when you do that, you should get about 5.6. Okay? If you have questions on how to plug that into your calculator, please be sure to reach out for some help. But you can plug this entire thing in all at once, okay? So if you tried to plug that in and you did not get 5.6, let me know so I can help you learn how to more effectively use your calculator. Why don't you go ahead and try to solve for side XZ? I'll give you a hint. You have to find the angle first. And the way you can do that is we know there's 180 degrees in a triangle. Good luck. All right, hopefully for this one you found that that third angle is 52 degrees. You set up your law of sines formula and you solved from there and ended up at 5.7. If your work matches mine but your answer doesn't, that means you plugged something into the calculator incorrectly. If your work does not match mine, please make sure that you ask questions on how to set it up, because if you don't set it up correctly, it doesn't matter how you use the calculator, you're not going to get it right. So be sure to ask those questions. So the last question had us look at finding a side length. Now let's look at how to find an angle. So if I want to find angle R, that would be this one right here. and I want to find angle S. That one's right there. I'm actually going to start by finding angle S because I have the opposite side. Whereas if I look at angle R, do you see how I don't know what that side length is, so I can't solve for that one yet. So I'm going to start by solving for angle S, and if I do that, I would set it up saying sine of 74 over 12.3 equals sine of x over 12.7. Again, you cross multiply, so I'd say 12.7 sine of 74 equals 12.3 sine of x. Divide both sides by 12.3, and I would have 12.7 sine of 74 divided by 12.3. Now, how do I get x by itself? I actually have to take the inverse of both sides. So on my calculator, hit second sine. My calculator will look like this. Then I'm going to type in 12.7 sine 74. I'm going to hit my division key, and then I'm going to type in 12.3, close my parentheses, and hit enter. And I'll find that this is about 83 degrees. So angle S is about 83 degrees. And if I wanted to set up another proportion and solve for that third angle, I could, but there's a faster way, and that faster way is using what we know about the degrees in a triangle. We know there's a 180, so I'm going to say 180 minus 74 minus 83. And if I type that into a calculator or do some mental math, I'll find that angle R is 23 degrees. And that's faster than doing law of sines again, so I'm okay with that. Why don't you go ahead and solve for angle O? In this case, again, just like the last one, you'll have to solve for a different angle before you can get angle O. Good luck. All right, hopefully you solved for angle N first and you got 28 degrees, and then you solved for angle O and got 82 degrees. If you have questions at all, please be sure to reach out for some help. And our last example is applying it to a word problem, okay? So the map shows the path a pilot flew between Omaha and Chicago in order to avoid a thunderstorm. How much longer is this route than the direct route to Chicago? So that means I need to figure out what these two distances are in order to find out how far the pilot flew so I can compare it to the direct route. Okay, so I start by solving for, I have angle 22. It means I'm going to solve for the distance between Omaha and the turning point first. So first I'm going to say sine of actually 113 because that's the side that's opposite the side I have. And then I'm going to say sine of 22 over x. And when I solve for that, when I cross multiply and divide, I would have x equals 471 sine of 22. And you can literally plug this into the calculator as I'm typing it. So 471 sine 22, close your parenthesis, hit your division key, and then hit sine, and then type in 113, close your parenthesis, hit enter, and you should get x equals 191.68 miles. So we know that this is 191.68. Now I need to solve for the other side. And the way I can solve for that other side is if I do 180 minus 113 minus 22, I get 45 for my angle. Or you can use law of sines and solve for that. Actually, no, you can't. the reason we can't use the law of sines to solve for that angle is we don't have the side opposite. So you honestly do have to do 180 minus 113 minus 22 in order to get that measure. And then I can set up another proportion. I can say sine of 113 still over 471 equals sine of 45. And how about I use y? Then if I cross multiply and divide, I would, in my calculator, I would type in 471 sine of 45 divided by sine of 113, and then I would hit enter, and when I do that, I should get that that distance is about 361.81. So then what I'm going to do is I'm going to type in 191.68 plus 361.81, and I know that my distance is about 553.49, and I want to know how much farther is that distance than the direct route, so I'm going to subtract the actual distance between the two, and I find out that it's about 82.5 miles farther. And that's my final answer. Okay, so I had to do law of sines twice. Had to use the information about how many degrees were in a triangle. And then I had to do some addition and subtraction to compare and find out how much longer something was. So now you're going to do that same process with some different values. Okay, so suppose the pilot chose to fly north of the storm. How much farther is that route than the direct route? So go ahead and try to solve this one. Good luck. All right, hopefully for this one, you said that it was about 19 miles farther. If you set up your law of sines, you should have found that the missing distance was 230.04 miles, and that if you add that to 260, your total distance traveled would be 490.04 about. And if you subtract the direct route, 471, you find out that your new route was 19 miles farther. So if the pilot was choosing between the way he went in the first example to this one would end up being a shorter distance, okay? So, concept summary, the law of sines, you set up your proportion, make sure it's lined up. Each fraction needs to have the matching angle and side, and you only need two of them in order to solve the problem, okay? One really important thing to note is some of you, I should have said this earlier, some of you were probably thinking to yourself, why don't we just use Pythagorean theorem or SOHCAHTOA? Those are reserved specifically for right triangles. Law of sines works with non-right triangles. That's why it's a really powerful tool. Tomorrow we'll talk about law of cosines, which also works with non-right triangles. If you have any questions at all, please be sure to reach out for some help, and have a great day.